Alright, let's have another example. So we're asked to evaluate the integral of 5x times fourth power of 4 minus 2x squared dx. Then, if you want to organize your integral, so you can rewrite this as the integral of 4 minus 2x squared, the fourth power times 5x dx. And by looking at the exponents, so it gives you a hint which will be u, which will be du. Okay, so if we set u as 4 minus 2x squared, now differentiate what is the derivative of 4 minus 2x squared. So 0 minus, so 2 times 2 is 4x dx. Now going back to your original integral, do you have negative 4x dx? The answer is no, you don't. What do you have? So you have 5x dx. Now how will we achieve our desired du if we have an issue with the constant, or rather numerical coefficient? Okay, so what we can do here is we can simply set aside 5 first. So we can rewrite our original integral as this one. So we have integral of, so we set aside 5, so put it at the left side of the integral sign. So 5 times, then copy the rest. So this is 4 minus 2x squared to the 4 x dx. This way, we can easily incorporate a numerical coefficient that would coincide with our neutralizing factor. Now, since du is negative 4x dx and we have x dx, so what will we do here? Okay, so what we can do here is we're going to multiply. So at the right, to get negative 4x, we multiply negative 4. At the same time, we find the neutralizing factor. So that will be, so 5 times, so copy the rest first. And then this portion here, so let's try to change. Okay, let's have negative 4. So asa nigikan? Kita ang nagbutang diha, so that we can get du. Okay, and then copy x dx. Okay, since we have multiplied a value here, so we already know what to do with the left side of the integral sign. We have to multiply your neutralizing factor. Okay, naman na say 5 diha, so you have to, so tapara na nimo sa NF, which is negative 1/4. Again, basis for neutralizing factor is your du, regardless of any other possible existing numerical coefficient. As you try to look at, so if you multiply all numerical coefficients, so you will get the original, which is 5, because negative 4 times negative 1/4, you get 1. Then 1 times 5, so you can go back to your original integral. Okay, this time, let's now apply the substitution. Okay, so this will now become negative 5/4. And then, since you already know your u, so this will be times integral of u raised to the fourth power du. So we have fourth power and then du. Then, so what will be the technique? So this will be using, so you have exponent, so power rule. So this will be equal to negative 5 over 4 times, so this will be u, so 4 plus 1, so 5, then over 5. So do not add c yet because we are yet to restore the original terms. Okay, so now we have your partial answer. Now you can cancel 5. You are left with negative 1/4 times restore u. This is 4 minus 2x squared to the power of 5. Okay, plus c. Rewriting looks awkward. Or we have negative 1/4 or negative, and then you may write this one at the numerator. So this will be, this will be 4 minus 2x squared to the 5th power all over 4 plus c. And that is your final answer, wherein you have a case where you have an existing numerical coefficient that had interfered with your desired du.